Alright guys, welcome back. We're going to have our final trig lesson today where we are going to look at application problems. A lot of trig application problems involve something called an angle of elevation or an angle of depression. So we want to take a look at how these angles are built, what this means, angle of elevation or depression. And we think of elevation as going up and depression as coming down. So let's look at this in terms of a right triangle. Do the same thing over here. Okay, the first thing I want you to realize is that I'm going to label thetas here. Angles of elevation and depression are always built off of horizontal lines. So when we think about them in terms of a word problem, let's think about, okay, this is the horizontal line. The eye of the person is here, and they're looking up at an object. So this is my angle of elevation. It's built horizontal off of the eye, and then from the eye up to the object. For the angle of depression, the eye is here. I'm looking down at whatever object. So the angle of depression is built from the eye, straight out the horizontal, and then back from the eye, looking down. That creates my angle of depression. Okay, so key words for each. If you're thinking about elevation, you think about things like looking up at something. Of course, elevation, ascends, be another one. Okay, and you might have, descends, looking down, land, like it's another one. Okay, so we've got our keywords. We know that they're built off of horizontal lines. So we got to remember horizontal lines are flat like the horizon. Verticals have a slope of 0, straight up down. Diagonals can either rise or fall. And then before we move on from the definitions here, I want you to just think about or realize one other little thing. Let's say I'm looking at this angle of elevation. I've got this horizontal line. If I did a parallel horizontal line up here, make them parallel, then this angle right here would be congruent because the parallel lines and transversal alternate interior angles are congruent. Same thing here. If I've got this horizontal and I were to kind of put in another horizontal here, making it parallel to the base of the triangle there, then again, this angle and this angle would be congruent. Again, alternate interior angles. All right, so let's take a look at a few scenarios and see if we can pick out whether the situation would be an angle of elevation or depression. Ava looks at a bird in a tree. So Ava would be looking up, so that's going to be elevation. Josh climbs up a mountain and looks down at the river below. Looks down, angle of depression. A plane is preparing to land on the runway. So we're going to be looking down from our plane to our runway. That's the angle of depression. Beth is flying a kite in the park. So she's on the ground looking up at her kite. That's going to be an angle of elevation. Okay, let's think about if we were going to draw the triangle to represent these different scenarios. Would these pieces of the triangle represent a horizontal line, a vertical line, or a diagonal distance? Okay, the height of a building, that'd be straight up and down, that'd be our vertical. The length of the runway, horizontal. The string of a kite from a person up to the kite, that's our diagonal. Distance from the base of a tree to a person, base of a pole to a person, base of a building to a person, base of the ladder to a person. All of those things are horizontal. Altitude of a plane. Altitude is from the ground to where you are, so that's a vertical. And a rocket launched at an angle is a diagonal. And a lot of times ramps, guys, ramps are diagonals. Also ladders. Those are famous diagonals. Okay, let's do some problems together. We always want to draw a triangle to organize our thoughts. So I'm going to look at this. The skier drops 51 meters vertically while skiing down a 120-meter ramp. So that's my diagonal, and that's a vertical. Okay, so let's just kind of diagonal, vertical, whoop, 51 meters diagonal, 120 meter at my ramp. What is the angle of elevation? Remember, that is from the bottom then looking up. So my eye out to eye up. So this is my theta. So I'm looking at this and I'm thinking, okay, back to our last lesson, finding an angle. I'm going to use inverse. I have my opposite and my hypotenuse. So I'm doing sine, and I'm using inverse of sine for an angle measure. I'm going to have my opposite 51 over my 120. There's my trig ratio. Remember, I'm multiplying them. That's going to equal my theta. So when I put this in the calculator, I end up with theta equals 25.2 degrees. That is my angle of elevation. Okay, let's do another one. A plane is 8,000 feet above the ground. That is an altitude. So that's going to be my vertical. And if the ground distance to the runway is 150,000 feet, ground distance, that is a horizontal. What is the angle of descent? Okay, so I can think about my little plane flying. This right here is my ground distance because it would be the same down here. So here's my plane, and I've got 150,000 ground distance. I'm 8,000 feet high. But I want the angle of descent, so I'm going to be looking down. Makes this my theta. So when I've got my picture drawn, now I can label. There's my right angle. Theta, this is my opposite. This is my adjacent. It is the tan ratio that uses opposite and adjacent. I'm looking for an angle, so I'm going to use my inverse tan times my ratio. I'm going to put this in the calculator to get my theta. Second tan, fraction button. Theta is equal to 3.1 degrees. And that's my angle of descent. Okay, let's think about this next one. Telescope is mounted 5 feet above the ground. The telescope is tilted at a 52-degree angle above the horizontal to see the top of a flagpole. The two are 20 feet apart. How tall is the flagpole? Okay, so I've got to think about this one. I've got myself a right triangle, and it says a telescope is mounted 5 feet above the ground. So if I think about my little telescope over here, this is going to be 5 feet above the ground is where the eye of the telescope is, basically. So that makes this 5 feet. Now, it says that I'm looking for the height of the flagpole. So this would be the x plus 5. It's going to be the full height of the flagpole. There's my flag flying up to the top here. It goes all the way down. Okay, and the two are 20 feet apart. So I know this ground distance is 20 feet. Once I've got my drawing, I'm saying what is the, tells me that the angle of elevation looking up at the top is 52 degrees. So I've got that. So now I know that, let's see, I'm looking for my opposite and I have my adjacent, so that's the tan. So here tan 52 equals my opposite, which is x, over my adjacent, which is 20. Multiply both sides by 20. 20 times tan 52 is 25.6. But in order to get the flagpole, I have to take the 25.6 plus the 5 feet that it's above the ground, and then my flagpole is 30.6 feet tall. Okay, let's look at another one like that. A 6-foot-tall bird watcher. So the person is 6 feet tall. We know this is 6 feet. Okay, bird watching is standing 50 feet from the base of a large tree, and the base of a large tree, so we're going to have some sort of a tree. We know that we are 50 feet here, so that's going to be 50 feet here. And we know that our angle looking up is 71.5 degrees. How tall is the tree? We've got the 6 feet here, and this is our unknown distance from here to here. So this is going to be angle of interest, opposite and adjacent. So once again, tan 71.5 is opposite over adjacent. 50 times tan 71.5 would equal our x value. Okay, so I'm going to have 149.4 equals x. So when I add x plus the 6 feet, the tree is 155.4 feet tall. Okay, got time on this video for one more, I think. The angle of depression from the top of the tower to the boulder on the ground is 38 degrees. If the tower is 25 meters high, how far from the base of the tower is the boulder? Okay, so when I'm thinking angle of depression, let's think here. I'm going to draw myself a little okay. Now this is my angle of interest, and I have my opposite and my adjacent. So tan 38 equals 25 divided by x. X times tan 38 equals 25. So x equals 25 divided by tan 38. Put it into the calculator. X is about 31.99, so approximately 32 meters. Okay. Remember, when your variable is in the bottom, you end up dividing with the other side. Okay, for 6, 7, and 8, I want you to try to do these on your own. Pause the video, and when you come back, I want you just to check your answers and check your ratios. Hopefully you did well. Hit me up with any questions either through It's Learning or in class, and I will see you in the next lesson. Have a good day.